Greetings and salutations, it's your friendly graduate assistant here for EDB 606, and today we're going to talk a little bit about the selection of your measurement instruments. By the time I'm done with this whole talk today, you're going to understand what scales and measurements are, what variables and measurements represent, and what the heck I mean by reliability and validity. So let's get right into it. You have your variable, which you've learned about before. Variables are subdivided into two distinctive groups: discrete variables and continuous variables. Discrete variables can be represented by nominal and ordinal measures. Continuous variables are represented by interval or ratio units of measures. If we check out what nominal is, it's basically, if it were computerized, it's a 0 or 1. It's one or the other. Are you male? Are you female? Are you Christian? Are you Jewish? Are you Muslim? Or are you other? It's one or the other. An ordinal scale is anywhere along the line. It could be not all religious, somewhat religious, religious, very religious. It could be very dissatisfied, dissatisfied, satisfied, or very satisfied. If you check out this graph, it explains it really well. Nominals, nominal units of measure, represent categories. The numbers don't reflect differences in magnitude. They only serve to distinguish groups. Nominal could be sex, nationality, clinical diagnosis, or college major. Up one level from that, you have the ordinal. And ordinals indicate rank or order of observations. Ordinal could be percentile, social class. Up a layer from that, you got interval. An interval is the equal distances between numbers. They represent equal distance in the amounts of whatever you're measuring. Could be year, could be degrees Fahrenheit. Ratio, units of measure, represent equal units from absolute zero. Observations can be compared as ratio or percentages. Stuff like distance, age, time, or weight. If you check out validity, which is an extremely important construct in research, validity is the degree to which an instrument measures what it's supposed to measure. Without validity, your research is pointless because you might not be measuring what you intend to measure. There's 6 distinctive forms of validity. There's content validity, which is the extent to which a measure represents all facets of a given construct. There's criterion-related validity, which is a measurement of how well one variable or set of variables predicts the outcome based on information given from other variables. You have concurrent validity, which is when a test correlates well with a measurement that has previously been validated. You have predictive validity, which is the extent to which a score on a scale or test predicts scores on a criterion measure. You have construct validity, which refers to whether scale measures or correlates with the theorized psychological or scientific construct that it's supposed to measure. And you have consequential validity, which refers to the intended or unintended consequences of a test, its interpretation, and its use. Now, if you didn't get all those, don't worry about it. You can just rewind this video. I know that was a lot of information thrown at you really quick. So let's check out reliability. Reliability is the degree to which an instrument consistently measures whatever it measures. This is different than validity. This is the degree to which an instrument consistently measures whatever it measures. Validity is measuring what it's supposed to measure. Reliability is consistently measuring whatever it measures. So right here we have stability, which is test, retest, inter-rater equivalency, internal consistency, split half reliability, and what we're going to be concentrating for the rest of this talk here, chrome box alpha reliability. Chrome box alpha is generally found on a scale of 0 to 1. When you look at a computerized printout, 0.5 chrome box alpha, that's just unacceptable. That's very weak reliability. 0.7/0.8, that's acceptable. 0.9 and above is absolutely excellent reliability. So if we look at a question, okay, we've got indicating the extent to which you agree or disagree with each of the following. So the students basically take this short survey. Here's an example of the questionnaire. You can see in this class, student interaction, yada, yada, yada. Strongly agree, agree, disagree, strongly disagree. So the students take all these answer all these questions. And when you run this through SPSS, which is a computerized analytical software, you get 4 different constructs. When you look at all those questions, you can subdivide them into 4 constructs. Think of the constructs as like subjects or areas of relation. The questions are surrounding 4 constructs, 4 areas of relation, 4 subjects. And when we look at this, we have all these numbers. Now these numbers, if you remember right, correspond to that Chrome box alpha that I was just talking about. And remember, Chrome box alpha is on a 0 to 1 measurement. 0 being very, very bad, it's not reliable whatsoever, 1 being extremely high. So if you look at these measures, question 17, 0.763, we got question 11, 0.785, so you can gauge reliability based on these numbers. So let's check out, okay, construct number 1, or subject number 1. It doesn't matter what the questions we're asking, we're just looking at the numbers right now. Construct number 1, we have a Chrome box alpha 0.866. That's really good. If you remember, like 0.7, 0.8, that's pretty acceptable. 0.9 is excellent. So this construct number 1 has a very high Chrome box alpha. It's very reliable. If we look at this printout right here, it's going to tell us a whole lot of information. These represent the questions. Question 1, question 2, question 6. These are all the questions which correspond to this construct, this subject. If we look at the Chrome box alpha, this is what happens if we delete this question. So if we take a look back, we have an overall Chrome box alpha of 0.866, okay, for construct number 1. If we delete question number 1, our Chrome box alpha, our reliability, actually goes down to 0.849. If we delete question 2, it goes down to 0.850. If we delete question 6, it goes down to 0.855. You can see together all of these actually represent a lower number than they all are together. So combined, all these give us a Chrome box alpha 0.866. However, if we delete any one of them, our reliability actually goes down. If we check out reliability construct number 2, we have an acceptable Chrome box alpha. We got 0.782. It's not great, but it's okay. We have 3 items. You can see if we delete this question, whatever the heck it is, our Chrome box goes way down to 0.547. So if we delete this, our reliability is not that strong at all. We lose a lot of power in this. If we delete question number 4, it goes down. If we delete question 3, well, we have originally a Chrome box alpha 0.782. Combined, these are more powerful. If we look at construct number 3, Chrome box alpha 0.810 for 3 items or 3 questions. Let's see, 0.858. What was it originally? Okay, so if we delete this question, our Chrome box alpha actually goes up a little bit. We'll have 0.810 or we'll have 0.858. But if we delete question number 7 or delete question number 8, it goes down drastically. And if we check out construct number 4, our Chrome box alpha is 0.812 for 3 items. And if we delete it, you can see that they all go down as well. So Chrome box alpha is basically a measure of power. It's reliability. It's on a scale of 0 to 1. And anything above 0.7 is pretty decent. Hope that you learned a little bit about the stuff that we covered today. If you have any questions, please feel free to ask in class. Thanks.